Hey there guys, welcome back. In the last lecture, we have seen how we can reverse the list and how we can sort the list in ascending order. Now let's see how we can arrange the list in descending order. We can do this in two ways. The first way is, in the sort method, we can pass a keyword argument reverse and set its value to true. This will reverse the list after sorting and we will get the list in descending order. The other way to sort the list in descending order is combining the two methods we saw in the last lecture. These two methods are sort and reverse. First, we will sort the list and then reversing it. This will sort the list in descending order. So let's see these methods in code. Making example k1.py. Suppose we have this list x.sort. First we'll see second way and then x.reverse, and now we'll print x. So sort method sorts the list in ascending order and after that we'll reverse the list. So we'll get the list in descending order. Let's run this. See, we are getting our list in descending order. Okay. Now let's see the first way. Making a new example k2.py. Suppose we have this list and x.sort. Here we'll pass the keyword argument reverse and assign it to true. Okay. By default, reverse is equal to false. That's why when we don't pass any argument, it sorts in increasing order, because in that case reverse is equal to false. The reverse here is the keyword argument. For now, just understand that keyword argument is we have to provide a name to the variable as we pass it into the function. We can't just directly pass the value of that argument. Okay. We will see this concept in detail in functions section. There you'll get it better. Okay. So print x and now running k2.py. See, we are getting the list in descending order. Okay. The next method after sort is extend. The extend method takes one argument and this should be any iterable like list, tuple or string. This method adds all the elements of the iterable to the end of the list. So let's see this in code. Making new example l.py. Here we have two lists x and y and x.extend y. Okay. We are calling extend on x object and we are passing y object as argument. Okay. Now print x and now running l.py. See, each element of list y is appended at the end of list x. Okay. So here we have two list objects x and y with some values. When we call x.extend y, each individual element of list y is inserted into x as new element, increasing the length of list by the number of elements in the added list, here y. So here the length of x will become 6. Okay, so do you remember the append method, our first method of class list? The task of append method is to add the element in the list, and so is of method extend. So how is append different from extend? Let's see. The first difference we can see is in the argument. Append requires any value in the argument. This value can be of any type, iterable or non-iterable, whereas extend requires an iterable as the argument. Append adds a single element to the end of the list, while extend can add multiple individual elements to the end of the list. If an iterable is passed in the argument of append, then it will be inserted as a single element, and extend inserts the individual elements of iterable in the list. Let's see this in example. Making a new example, m1.py. Here we have two lists, x and y. X is the list in which we will append another values. Okay. X.append 22 and print x. And now running m1.py. See here 22 is appended at the end of the list. Okay. Now x.append. Here we'll append y. Okay. So let's see, running m1.py. Okay, see here y is appended as a single element in list x. Okay. Now we'll see extend. So comment this and x.extend 12. We saw that we can't pass any non-iterable in extend. So let's see what happens. Running m1.py. See here we are getting type error. Int object is not iterable. Okay. Here this error is saying that this int object, that is 12, it is not iterable. So we can't pass any non-iterable in extend. Okay. Now comment this and x.extend y. So here we are appending list y in x. Here this y will not be added in the list form. Instead, each individual elements of y is added in the list one after the other. So let's see. See, we are getting two different elements. Okay. Unlike append, extend inserts the individual records in the list. Okay. So this was the first difference. Now let's see new example, m2.py. Suppose we have this list and we'll append a string in list x. Okay. So x.append, let the string be test and we'll print x. Now running m2.py. See, in append our test is the last record of the list. Okay. Now comment this and x.extend test. See, this example will clearly differentiate between append and extend. Okay. So running this example. See, here extend is treating each character as a single record. Okay. That was same in the case of list. When we were passing y in extend, that was the similar case. Okay. So we saw the difference between extend and append in the example. Now let's make a new example, n.py. Initially, we saw that our last index of the list is -1. In this, we are actually going to prove it. Okay, so let's see. Suppose we have this list and we'll print each element of x. See, here I have lots of print statements. These are nothing but the elements of list. I have written them in two types of indexing. So positive indexing is understood, I guess. In negative indexing, I have started from right, that is -1, and we'll go up to first index. Here in this case it is -7. We can see that the length of our list is the first index when we start from -1. Okay. And also here I have the keyword argument in print function. When we use print function, we get the new line after the statement is printed. So using this argument end, we can control where our print statement should end. By default it is \n, that is new line. So here I have used space. So we'll get the elements separated by space, and after the last element we will get a new line. Okay, here we are printing the elements two times in different ways, so we will get two same lines in the output. Let's see. See, for index 0 and index -7 we are getting 12. For index 1 and index -6 we are getting 14. For index 2 and index -5 we are getting 61, and so on. Okay. So here we can see the negative indexing of the list. Okay. Now making a new example, o.py. Here we have two same list, x and y, and we have a new variable z is equal to x, and we will print id of x and print id of y and print id of z. So here we have seen that the list is mutable, so the list objects are not reused. So x and y are two different objects, but here we have assigned the value of x in variable z. So is that the same object that is assigned to variable z, or a new object is formed? We can see that by the IDs. Okay, so running o.py. So here our IDs of x and z are same, and the ID of y is different. Okay, here the reference code of x is assigned to z. Okay, so this copying of a collection structure is known as shallow copy. Here the elements are not copied. With a shallow copy, two collections share the individual elements. Other than this, we also have a copy method in class list. This method does deep copy. Deep copy of a collection is two collections with all the elements in the original collection duplicated. So let's see. Z is equal to x dot copy, and running o.py. Look, here all the IDs are different. Okay, here a new list object is created with the same values as x, and its reference is assigned to z. Okay, this is known as deep copy. Here a new list object is created. Okay, let's see this with the help of diagram. We have two similar lists, but as we know, list is mutable, so two different objects are formed for each list, and their IDs are assigned to their respective variables. For the first case, where z is equal to x, the reference of this list is simply assigned to variable z. So ID of x will be equal to the ID of z because they are the same object. So if this object has ID 1 and this has ID 2, then the ID of z is equal to 1. For the second case, where z is equal to x dot copy, a duplicate object of this list object is created, and this is a new object, so it will have a separate ID. Let's say ID 3, and its reference is assigned to variable z. So we'll get different IDs for all three. That is, ID of x is not equal to ID of y is not equal to ID of z. This is shallow copy, and this is deep copy. Okay, so now we came to the end of the list data type, and here's a task for you. You have given a list and a target value, and you have to write a program to print the indices of the two elements from the list whose sum is equal to the given target element. For example, the given list is this, and the target value is 3. So your output should be 0 space 1, because the element at index 0 is 1 and the element at index 1 is 2, and 1 plus 2 equals 3, which is equal to the target value. And if there are no elements, simply return none. So solve this and share your code. I'll look forward for your solutions. Okay, so see you in the next lecture. Until then, take care and solve the problem. Bye bye.